I'd like to take a look at just one question from our homework last night. That's page 533, question number 2. Anybody feel like they got that question? That's a challenging question. That's a real challenging question. Probably more difficult than we're going to see on a quiz or on a test or on an exam. But it's good exercise for us, good mental exercise for us. It makes us smarter when we do a question like this. Even when we attempt a question like this, it makes us smarter. We're going to go over it right now. I want you to be able to understand what we're doing, but don't panic about being able to actually do it, because you're probably not going to have to worry about doing it. Just follow through so that you understand what we're doing, okay? It says, in the situation described above, if the first and third spheres remain at their original positions, where would the second one need to be situated so that the net electrostatic force is 0? All right, well, let's draw this out. We have charge number 1 right here. Its charge is negative 2.5 times 10 to the negative 9 coulombs. It's 1.5 centimeters to the left of another one. There's a third one over here that's to the right of the other one. Call this charge 3. Charge 3 has a value of negative 1.00 times 10 to the negative 9. And charge 2, I'm going to draw it in a different color here because we don't know exactly its position. Okay, it's in there somewhere in between 1 and 3, but we don't know what its value is, what its position is. Its charge is 1.5 times 10 to the negative 9 coulombs. We know the distance that separates 1 and 3 is going to be 3.5 centimeters or 0.035 meters. That's all we know. Okay? Charge number 2 is somewhere in there, certain distance away from number 1, a distance that's smaller than 0.035 meters, but how much smaller, we don't know. Yeah, let's draw a free body diagram because that's what we do when we see any question like this, whether it's a real challenging one like this or a simpler one. Charge number 2 is positive, so it's attracted towards number 1. Charge number 3 is negative, so it pulls number 2 towards it as well. What do we know about those two forces if the net force is 0? What do we know about F1 and F3 too if the net force is 0? Yep. They've got to be equal to each other, or at least the magnitudes have to be equal, right? The direction is opposite, of course. We're going to say F12 is equal to F32, or the magnitude of F12 is equal to the magnitude of F32. All right, well, let's sub in some expressions here. Let's say K times Q1 times Q2 over R squared. Oh, we're gonna define R then. We're gonna make R, this distance right here between 1 and 2, is equal to K times Q2 Q3 over, we can't say R anymore because this distance right here isn't R. Anybody want to take a stab at what this distance is? The total distance is 0.035. The distance from 1 to 2 is R, whatever that number is. The distance between 2 and 3 is 0.035 minus R. Does that make sense? If you add R and 0.035 minus R, then you're going to get 0.035, which is the total distance. This is looking pretty ugly here right now. I'll tell you what, though, we can simplify it a little bit. K cancels out because it appears in both terms. Q2 cancels out because it appears in both terms. R appears in both terms, but not in the same way, so we can't cancel it. We're left with Q1 over R squared equals Q3 over 0.035 minus R squared. All right. Let's sub in some numbers here. Q1 has a value of 2.5 times 10 to the minus 9 coulombs over R. Q3 has a charge of 1.0 times 10 to the minus 9 coulombs over 0.035 minus R squared. Look, I can simplify it a little bit more by canceling out the 10 to the minus 9. I don't have to do that, but 10 to the minus 9 appears in both terms, so if I can make it simpler, let's do that. It's starting to look a little bit better here. I get 2.5 over R equals 1 over 0.035 minus R. Everybody with me so far? Terry? Over R squared, yes, thank you. With me so far? All right. here's what I want to do now. I want to get these R's up on top. So what I'm going to do here is cross multiply. I end up getting 2.5 times 0.035 minus R squared equals R squared comes up, multiplied by 1, just gives me R squared. Good? Boy, how do you solve for R here? I mean, we've got one variable that we're looking for, and that's going to be the position of object number 1. But how do I solve for this? I'll tell you what, the first time I did this question, I was thinking, oh, we're going to have to do like a FOIL thing, right? You guys remember what I'm talking about from math class? But then it occurred to me, no, we don't have to do a FOIL thing. It's much easier than that. Let's square root both sides. Can I do that? I can do whatever I want as long as I do it to both sides. I can multiply both sides by 16,112.2 as long as I multiply both sides by that number. It wouldn't make any sense to do that, but I could. If I want to square root both sides, I can. So let's do that. If I do that, tell me what the square root of 2.5 is. 1.58? 1.5811? Okay. Now the square root of 0.3035 minus R squared is 0.035 minus R. Square root of R squared is R. Now it's looking better. The squares are all gone. Now what I'm going to actually do is a couple of options here, but what I'm going to do is take the 1.58 over by dividing. Okay, take this over by dividing. Leaves me with 0.035 minus R on the left-hand side equals 1 divided by 1.58. Somebody want to calculate that for me? Let's do this for a second. 1 divided by 1.5811. I get 0.6325 R on the right-hand side. See what I've done there? That makes sense? Okay, I've taken this over by dividing. Basically, on the left-hand side, I'm going to get 1 over 1.5811 R, and I just simplified it by making it a decimal. Let's take this R over by adding. I get 0.035 equals 0.6325 R plus 1 R is 1.6325 R. Right? 0.63 plus 1 is 1.6. And then I'm going to say R is equal to 0.035 divided by 1.6325. And when I do that, I end up getting, I think, 0.02. Is that right? 0.035 divided by 1.6325. .0214 meters. All right, look at this. 0.0214 meters to the right of the first charge, because that's what R is, right? So the second charge is 2.1 centimeters to the right of the first charge. Now you could say it's about 14 centimeters away from the third charge, but you don't need to describe it in terms of 2 frames of reference. Okay? We can describe it easily just in terms of the 1. So 21 centimeters to the right of the first one, which is exactly what they have for our answer there. Now, has the method that I've used made sense there? Yes? If it does, you're smarter than you were 10 minutes ago. You know what? Even if it doesn't, you're still smarter than you were 10 minutes ago, just not quite as smart as you would be if you got it. Don't panic about being able to do this mathematically, okay? Just work through it so that there's connections made in your brain to make your brain smarter for other questions. All right, that's it for today. That's it for the week. Have a good weekend, and we'll see you on Monday.